What is the light? How can we uncover its mystery? The nature of light appears to be elusive, as light behaves unnaturally. Thomas Young was the first person who tried to reveal the nature of light. In his experiment, light passed through two slits. If light were a bunch of particles, part of it would land directly behind the first slit and the rest behind the second slit. This is similar to the way balls kicked would land in the parts of a goal to the sides of the keeper. However, light plays a trick on us, and it lands exactly in the middle. From such results, Young concluded that light is a wave. However, we cannot surf on this wave for long, as at the end, we may come up against a brick wall or perhaps a metal plate. Light that falls on such metallic plates ejects electrons. This phenomenon is called the photoelectric effect. What if light was a particle? Then the huge number of particles should eject a huge number of electrons. However, the intensity of light has no influence on the number of emitted electrons. We can use intensive red light without ejecting even one electron. Meanwhile, using just a bit of blue light, one with higher frequency, we can emit thousands of electrons. Imagine this phenomenon. It is as if small, dense waves go on a rampage, whereas a huge tsunami passes meekly. To solve this problem, Albert Einstein proposed photons, small particles whose energy is larger when their frequency is higher. When scientists pondered what to do with the conclusions made by Young and Einstein, the issue became even more complicated after Heisenberg's revelation. He introduced the uncertainty principle, which argues that when we know better the location of a particle, we lose information about its momentum. The existence of an observer interrupts the results of the research. Let's imagine how controversial this theory was. For the first time since Newton, someone had contested the idea of the experiment as a proper research method. The lack of an experimental method brought back the charm of physics. Being wrestling combined with a philosophical catfight. Is light a wave or a particle? Niels Bohr, in his theory, called the Copenhagen interpretation, argued that before the act of observation, light behaves as a wave and a particle simultaneously, a superposition of both states. Depending upon the type of experiment, the observer destroys one of light's properties, and it then appears as either a wave or a particle. Such a proposition was unacceptable for Schrödinger, who continued the fashion of creating thought experiments that existed then among physicists. He proposed a now famous experiment in which he brought to life Schrödinger's cat and killed him at the same time. In this experiment, the cat is placed in a closed box with a radioactive isotope and a Geiger counter, which triggers a poison. If the isotope starts to radiate, and that is a perfectly random event, the cat will die. If not, the cat lives. According to the Copenhagen interpretation, the cat is both alive and dead simultaneously. Only after the observation are we able to ascertain in which state the cat exists. Schrödinger's cat became the paradox that best highlights the differences between the quantum world and our reality. Being an essential part of quantum basics, the cat often appears as an icon in publication about quantum mechanics. Returning to the question, what is the nature of light? It is the same as that of the cat, full of mystery.